So what we did was we looked at simulations of the North Atlantic storm track. So we're talking about the jet stream over the North Atlantic in winter. It's the only season and region that we've looked at. And when we look at simulations of this in a climate model, looking at conditions when carbon dioxide has doubled, the jet stream strengthens, and this means that measures of clear air turbulence that are used by airlines and aviation authorities will increase by up to 40 to 170%. 170 was the large end.
So, because of climate change and global warming, more carbon dioxide going into the air, and therefore the jet stream getting more powerful. That's the gist of it.
Absolutely.
What's your time scale for this? Because when we talk about global warming, it's always a 1 degree over this number of 20, 30 years. What's your time scale?
The time scale over we looked at, doubling carbon dioxide, would probably happen around mid-century time. Of course, that depends on how much carbon we continue to emit into the atmosphere.
Is this a gradual change, so over the next 5 or 10 years you would expect, as more carbon dioxide goes into the air, turbulence to increase?
It's a good question. We would expect it to increase gradually, but there could be surprises, and we are looking at these sorts of effects in our future work.
Are planes built to withstand the sort of turbulence that you are forecasting could happen?
We think they are, in the sense that more turbulence will happen more often. In terms of extreme turbulence, it's always a bit of a cost-benefit thing of how you build any sort of engineering. We've got to be very careful about advocating for entirely different kinds of planes. At the moment, this is merely a study talking about how turbulence may change in the future. Going to the engineering viewpoint would be something we'd be very careful about. We haven't looked at that yet, I stress that.
And when the jet stream strengthens and becomes more aggressive, as you described, is it actually getting stronger, or is it just getting more disruptive?
It's a couple of things. The average winds are predicted to get stronger at those levels, about 10 kilometers up in the atmosphere. But storms themselves, individual storms, may become more severe as well as the atmosphere warms up and there's more water vapor in the atmosphere. But it's a good question. Exactly what the distinction is between the two, the average and the storms, we need to look at.
Right, so the plane could be either facing heavier headwinds or being pushed by stronger tailwinds, as well as being buffeted by the storms en route.
That's potentially possible.
And we're talking, what, flight level 31,000 up to 39,000?
Something like that. We looked at about 10 kilometers up in the atmosphere, so it's that sort of level, cruise altitude.